Hi there, welcome to my channel. Hope you are doing well. In today's video, we will be solving this easy lead code problem. Check whether two strings are almost equivalent or not. Let's understand the problem first. They are saying we have two strings, word1 and word2, and they are considered almost equivalent if difference between the frequencies of each letter from A to Z between word1 and word2 is at most 3. What does it mean? If we look at the example, we have word1 and word2. In this case, if we see frequency of letter A in the first string is 4, while it's not present there in the second string. So the difference is 4, which is greater than 3. Hence, these two strings are not equivalent. What are they saying further? Given two strings, word 1, word 2, each of length n. So we need to focus here that both the strings are of equal length n. Return true if word 1 and word 2 are almost equivalent, that is, if the difference of frequencies is less than or equals to 3 only, or otherwise false. The frequency of letter X is the number of times it occurs in the string. In this case, it was 4. If we look at word 2, here the frequency of B is 2 and frequency of C is 2. Let's see the example 2 now. In example 2, this is the word 1 and word 2. Now here A appears 1 times in word 1. We can see A here is 1 times, and in this string we have A1, A2, A3 and A4. So the difference is 3. The frequency difference is 3 for A. Now we can check the B. B appears once in word 1 and in 2 it appeared 1. So difference is 0. The letter C appeared once in word 1 and in word 2 it appeared 2. So difference is 1. The letter D appeared once in word 1 and here it's not there. So difference is 0. Sorry, difference is 1. It is 1. Then E appeared twice here and it's not present here. So again the difference is 2. And F is once here, but it's not present here, so the difference is 1. In example 2, the difference between frequencies, the maximum one is 3. Hence, these two words, word 1 and word 2, can be considered as equivalent strings. In example 3 also, the frequency is counted and then it is found that the output is true. If we see the C letter came 3 times in word 1, it's not there in word 2, so the difference is 3. Then D came twice here and it's not present in word 2, so the difference is 2. Now A came twice here in word 1 and in word 2, 1, 2, 3, 4. 4 times it's here, so difference is 2. Now B came twice in word 1 and in word 2, 1, 2, 3, 4, 5. So the difference is 3. Now we can see the maximum difference is 3. Hence word 1 and word 2 can be considered as almost equivalent. That is why the output is true. Let's have a look at the constraints also. They are saying that the n is equal to word 1 dot length, that is equal to word 2 dot length. It means that both the strings are of equal length. The other constraint is the length should be less than or equals to 100. This means that both the strings can have maximum of 100 elements and at least one element should be there. The strings cannot be empty. Then there is one more constraint. Word 1 and word 2 consist only of lowercase English letters. So we will not be getting any uppercase characters or any special characters in the strings. Only lowercase English letters will be there, which will be A to Z. To solve this problem, we can keep a track of frequency of each letter in each string and then check whether the difference between the frequencies is greater than 3 or not. If it is within 3 or equals to 3, then we will consider them equivalent, and if it is more than 3, then we will consider them as non-equivalent. So let's see how we can do that. We can use dictionaries to maintain the frequency of each letter and in each word. So let's say we have two dictionaries, one for word 1. There we can have count of letters in word 1, and then we can have one more dictionary where we will have count of letters in word 2. Once we have values for both the dictionaries, after traversing over word and word 2, we can try to find out the difference between the values of same keys for the both the dictionaries. So if the difference is within the range of 3, then we will return true. If it is beyond 3, we will return false. Solving by this approach, we would need two dictionaries, one to keep the count of frequencies in word 1, other to keep the count of frequencies in word 2. Then we have to loop twice here to word 1 and word 2. And then while counting the difference again, we need to loop through these complete dictionaries, and then we will get the result. Instead of doing all this, we can do it in less time and space complexity following the same approach. Let's have a look at that. So instead of having two loops to get the frequency of each word, we can do that in a single loop. Why? Because both word 1 and word 2 are going to have the same length. Now, in the same loop, we can count the frequency of letters of word 1 and word 2. About the dictionaries, instead of maintaining two different dictionaries for word 1 and word 2, what we can do is we can keep the track of frequency of letters in a single dictionary. For example, this count word 1. So what we will do, whenever a letter is found in word 1, we will increment count here, and whenever it is found in word 2, we will decrement the frequency. Now at the end, when we have traversed through word 1 and word 2, we just need to find out if there are any values which are greater than 3 in this dictionary. If there are such values, then we will return false, and if there are no such values, we will return true. Our dictionary will have keys something like this A, B, C, D, E up to Z. Now we need to keep track of frequencies for each letter. If we check in this example here, in word 1, A is coming 4 times. So when we are traversing through word 1, we will have word 1, 0 element, and we will add 1 here. At word 2, we will do the -1 for B. Now this is at 0th index. Now at index 1, again we will do +1 for A. So it will be now 2. For word 2, we found a C here. So now C will be -1. This is happening because for word 2, we are doing a decrement, and for word 1, we are doing an increment. Now at position 2, frequency of A now will be 3. And in word 2, we found a C. So this will become now -2. At index 3, again in word 1, we have a again. So the frequency will be 4. And in word 2, we have a B. So now B will be updated to -2. Now at the end, what we see is the difference of frequencies of A is 4, B is -2, and C is -2. Here we need to consider the absolute value of difference between the frequencies. This will be considered as a positive case for equivalent strings. This again is a positive, but 4 here it is making them non-equivalent. Hence we will return false. We can conclude on this number line, if the difference between frequencies is between this range -3 to 3, then the strings are almost equivalent. But if the difference is beyond this range, then we will say they are not equivalent. Let's try to code this problem now. We will take one dictionary count, and we will use collections to initialize this dictionary. By using collections, we will always have a default value for all the keys in the count dictionary. What will happen if we don't use the collection default dictionary? In that case, we always need to make sure that if a particular key exists in the dictionary or not. So using the collections.default dictionary, we do not need to check if value for a particular key exists or not. It will by default initialize this. So in our case, we will initialize it with int values. After this, we will loop through the strings and try to find out the difference of frequencies for each letter. So we will loop through for I in range length of any string. We will say word 1 here. So whenever a letter from first string is encountered, we will increment the frequency by 1. And whenever a letter from word 2 is encountered, we will decrement the frequency. After this step, we will have a dictionary ready with keys as letters from A to Z and values as difference of their frequencies in both the strings. Now we need to cross-check if there are any frequencies where difference is greater than 3 or not. Let's do that now. If count of k is greater than 3 or if it's less than -3, then we will return false. In other cases, we will return true. Let's see what Leetcode says about this solution. It's accepted. We will submit it now. The solution is submitted successfully. Here we are defining a dictionary which will have at most 26 keys because we are only having keys for letters A to Z. So it will take space of order of 26. This loop is being executed order of length of word 1 times. We can say that its time complexity is order of n, that is a linear time complexity. Again, we are having this loop which we are executing order of 26 times because count is having maximum 26 keys. So these are the time and space complexities for this particular solution. If you have any better solution to this problem, please let me know in the comment section. Or if there are any suggestions to enhance this particular solution, those are also welcome. For more such videos, please visit my channel. Thank you so much. Bye.